Alright, so for this one, we're going to factor the top and the bottom completely. The bottom doesn't factor because x squared plus 1 does not factor. So the domain of this thing is all x such that x are real and x cannot be 2. So at x equals 2, we have a hole because it's removable discontinuity. I'm not going to cross it off, but if I wanted to, I could cross that off. So there's a hole there. Now, whatever makes the top 0 is also x-intercepts. So I know that there's x-intercepts at 1, 0 and at negative 2, 0. I don't say there's not an x-intercept at 2, 0 because it's a removable discontinuity. It's a hole. If I want to find out where the hole is, which is a good idea, it's going to be at 2 something. How do I find the height? Well, I temporarily can use plug 2 in to the function if I did cross off or remove the discontinuity. So I would get 2 minus 1 is 1 up top, 2 plus 2 is 4, and then 2 squared is 4 plus 1 is 5. So we're getting 4/5. So there's a hole at 4/5. There are no horizontal asymptotes because, again, x squared plus 1 cannot be factored, which means there is no x value that can make that 0. If I tried to solve it to make an x value that makes it 0, I end up getting the square root of a negative. So there is no vertical asymptote. For the horizontal asymptote, there is one because the degree up top is 3. If I multiplied out the top, right, so the top was x minus 1 times x squared, I would get an x to the third and a whole bunch of other stuff. The coefficient is 1. On the bottom, if I multiplied out the bottom was x minus 2 times x squared plus 1. If I do the x times the x squared, I get x cubed. The coefficient's 1. I'll get some other stuff. But I don't care when they're the same. When the powers are the same, I divide the coefficients. So the 1 divided by the 1. So I've got a horizontal asymptote at y equals 1. So with all this information, I start graphing.
It's almost like she's trying to sing like happy birthday.
All right, so let's graph this. I've got.
Did anybody take flowers to the cemetery, Seal? Did you know? No, they didn't, see? I remember a couple of times when.
Got x-intercepts at 1, 0. At negative 2, 0. Got a hole at 2, 4/5. So like right there's a hole. And there is no vertical asymptotes, but there's a horizontal asymptote at 1.
I always leave it in my car. I always leave it in my car that's sprayed up when I go.
So now I need to just start picking some x values and getting y values. So I'm going to say x and y. I'll try 0 for x. Which version of the function will I use? I'll use x minus 1 times x squared minus 4 x minus 2 times x squared plus 1. So if you plug in 0, we get negative 1 times negative 4, negative 2 times 1. I get 4 over negative 2. I get 0, negative 2.
Julian has Snapchat?
If I plug in 3, I get 2 times 5,
So just do it on the
1 times 10. So I get 1.
Because you don't say anything and you just have it in your phone.
Remember, it's okay if you cross or touch an x a horizontal asymptote. So now I'm going to plug in a 4. When I plug in a 4, I get a 3 times 12 over 2 over 17. So that's The 2 goes into the 12 to make it a 6. So I get 18 over 17. That's just over 1. Then when I plug in a 5, where are these guys? I should start to approach. So it looks like we're doing this kind of thing. Hole there. Comes up here. And then it's going to approach the asymptote the rest of the way. So just to make sure it stays above there, I'm going to go plug in 1, 2, 3, 4, 5, 6. I'll plug in 6, not 5. 6 minus 1 is 5. 6 squared is 36. Minus 4 is 32. On the bottom, I got 6 minus 2 is 4 times 37. The 4 goes into 32, 8. So we get 40 over 37. Yeah, that number is above 1 slightly. So it's a little bit closer. Whoops, sorry. It's a little bit closer. So that's what happens over there. On this side, it looks like it's probably just going to stay underneath and approach the asymptote. So I'll plug in like 1, 2, 3, 4, 5, 6. I'll plug in negative 6. Almost. Last one. Negative 6. I plug that in. So the negative 6, I'm going to go negative 7. 36 minus 4 is 32. Negative 8 times, I put a negative 6, 36, 37. So this reduces to a 4. So we'll get negative 28 over negative 37. That's less than 1. That's 28 over 37. It's close to 1, but less. 2, 3, 4, 5, 6. So that's how that graph looks.